If you want to crush that calculus exam, you got to stop making some of the mistakes like we're going to see below. So like and subscribe to the video like a ninja, and let's get started. Huh! Say I gave you this derivative problem, e to the 3x sine of x. For a problem like this, I like breaking it up into two sides, so I would start with the left-hand side personally to just simply find the derivative of the e to the 3x part itself. Now, I'm going to claim that the answer of the derivative is simply e to the 3x. Can you tell me what I did wrong in the comments below? Okay, so if you remember, the derivative of e to the x itself is pretty simple. It's simply e to the x. But this is a different case because the power here is actually 3x. In a situation like this, it's helpful to look at the original function as a composition of functions. Do you remember how you can compose functions so that you have f of g of x? And what I mean is I'm going to go ahead here and split this function up into two parts. I'm going to call f of x simply e to the x, the simpler elementary function. And then I'm going to say the power g of x is 3x. And then we can rewrite e to the 3x as a composition in such a way where we plug in g of x into the original function. And so f of 3x gives you e to the 3x. And the reason why I'm doing this is because when you have a composition of functions like this, we could then use a derivative property known as a chain rule. And so for the chain rule, what it's basically saying is that we would take the derivative of this outer f of x function times the derivative of that inner function we composed it with. And you can use a u substitution here, by the way, and I have another video on that. But it's simpler, so I'm not going to do it personally. E to the 3x then would have a derivative where it's the outer function e to the 3x. So you can think of it as e to the u having a derivative of simply e to the u, where u is this g of x function 3x, times the derivative of that inner function, the power, or u, which would be 3x. So then we'll find that the derivative of e to the 3x is in fact 3 e to the 3x, not simply e to the 3x. Okay, so going back to the original problem, right? We want to find then the derivative of this e to the 3x sine of x. We already did the left side, so we want to bring it all together. So I'm going to claim then that the answer is simply 3 e to the 3x, like we found above for the left, times sine of x. Now, what on earth did I just do wrong here? I made a huge blunder. Can you tell me below in the comments how you would fix this? Okay, if you've been paying attention to some of the other videos, you'll notice that we need to use something here called the product rule. E to the 3x sine of x is a product of two functions, e to the 3x and sine of x. And if we call those functions f and g, then with the product rule, what it's basically saying is the derivative of everything is the same as the derivative of that left f function times the right, plus, now you swap it, the derivative of the right function times the original left one. And so if we were to plug everything in here, we would find that for f of x being e to the 3x and g of x being sine of x, when we find this product rule, we would take f prime times g. F prime we already found above, right? It's 3e to the 3x times g, which is sine of x. And finally, plus e to the 3x, which is just f, times the derivative of g, which is cosine of x, because when you take the derivative of a sine, you get cosine of x.